So one of the things we can do is figure out how old the universe is. Well, that's pretty straightforward because we can see that the universe is expanding. And so imagine I think about my trajectory of two galaxies getting larger and larger in time. Then they follow a trajectory. I measure the slope of that line. That is essentially the slope on Hubble's diagram, just measured the opposite direction. So the slope of that line tells us how fast the universe is expanding and allows us to run the universe back and figure out when did the Big Bang occur. So if we can measure the slope of that line, the expansion rate of the universe now, we can figure out how old the universe is. And that was something that had been worked on since literally the time of Hubble. Hubble got an answer that the universe was less than 2 billion years old. That was problematic. We already knew that there were things at least that old on Earth. And then the Hubble constant became a real, war between competing teams of whether or not the universe was expanding at one rate, which we would say is around 50 kilometers per second per megaparsec, or another rate which was more like 100 kilometers per second per megaparsec. And the Hubble key project was to use the Hubble Space Telescope. Indeed, this was the key thing that the Hubble Space Telescope was built to solve, was how fast the universe was expanding. So we could know how old it is. And so in roughly 2001, I would say the Hubble Key project came up with its answer, which was that the universe was expanding at approximately 70 kilometers per second per megaparsec. And that tells you that the universe is about 14 billion years old. So it's a useful marker that we have. And I should say I was pretty happy about that number because my PhD was measuring the expansion rate of the universe, and I got 73, which turns out to be pretty close to the current accepted number. Certainly within my thesis uncertainty.